All right, folks, we are back again to do the beginning of kind of a precursor to Chapter 2, let's call it. We'll call it 2.0 or 2-0. I am going to switch over here, and it's about polynomial division. Now, again, as we can say through almost every section this year, you've done something with this, but we're going to always assume you don't remember anything. So let's look at what a polynomial division problem. I'm just going to do some examples. I think this is the easiest way to kind of lead into this stuff. So in its most basic form, this is kind of the first way, is when we have monomial division. All right, I just need to get that. If we have monomial division, or division by a monomial, this is the best way to say that, you would have a problem something like this, where you're asked to solve or find the quotient. Either of these would be your directions. All right, a quotient meaning the result of division. All right, so now what does the problem look like? It would be something like this. If I had 4x cubed plus 9x squared plus 5x minus 3 all over, let's say, 2x. Now, the idea of this goes back to the same thing you always did. As many of our things with polynomials do, they work on the same rules as all your arithmetic. If I was dividing 4 different numbers by a single number, like think of this. If I had something like that, couldn't I rewrite that this way? Right? That's what we did with numbers. We kind of did it backwards. A lot of times we went from this to this, right? We got a common denominator, we put it all over one and added them together, but these don't add nicely together. So we may want to go backwards to simplify this. So what we're going to do is we're going to say this is equivalent to 4x cubed over 2x plus 9x squared over 2x plus 5x over 2x minus 3 over 2x. Again, I want you to realize the key characteristic here is we have a polynomial of many terms, or any number of terms, divided by, or a polynomial of many terms, and we have a monomial on the bottom, a single term dividing into each of these pieces of a larger polynomial. So we can do it this way individually, just like we did with numbers. Again, just to remind you of that. So now it becomes a problem similar to what we did in the previous chapter, where we looked at exponential rules, and we started to look at these things and say, wait, now 4 over 2, and again, the way I always think of this, guys, is I just take the numbers over the numbers. So 4 over 2 would be 2 on top, because this I can think of as 2 times 2 and cancel one of them. And then x cubed over x, I think of that as x times x times x. In other words, I got 3 of them multiplying on top, I got 1 on the bottom. So 1 from each will cancel, leaving me 2 on top. So this would just become 2x squared. Here, I got a 9 over 2. Nothing changes that, right? That doesn't divide nicely. So I would leave that as 9 over 2. Now I have an x squared over an x. So there's 2 on top, 1 on the bottom. That leaves 1 on top. All right. Now, go to the next one. 5 over 2. Again, no nice division there. So I leave it as 5 over 2. The x's cancel. X over x. So I can get rid of that little tail I got left there and go to the last one. And this one, the 3 over the 2 does not change. The x's do not cancel. So this would be that result of the division. That is the quotient. So that is the solution to that division. All right. Again, this is when we have a polynomial of more than one term, or one term or more, over a monomial, polynomial of a single term. All right. So that's our most basic form of division. Now, my personal favorite for division, and I know there are those that don't like this, I tend to think I like it because it always works. All right, it's that simple. This will work for any polynomial divided by any polynomial, including the one we just did. No matter what, this works. So this is called long division. And this works on the same principle, again, as your arithmetic from elementary school. When we do long division, it's when we have a problem that's a little more involved. Something like this. If I have 3x cubed minus 7x squared plus 9x minus 14, and I am going to divide that by x minus 2. All right, so looking at this, I've got a polynomial on top of more than one term, and the same on the bottom, more than one term polynomial. What we can do is the same thing you did when in elementary school you had, say, 132 divided by 6. You remember long division, and you might not. It's been a long time since you've been asked to do this, but you did this. And 6 didn't go into 1, so you went to the next thing and said 13. 6 goes into 13 twice. I multiply, right? After I figure out it divides in twice, then I multiply, I get 12. And then I subtract, and I get 1. And then 6 goes into 1. No, but I can bring down the 2. 6 goes into 12 2 times, and I get 12, and I have a remainder of 0. So if anything had been left there, that would be a remainder. We can do the same thing here. I'm dividing by x minus 2. So I'm going to put x minus 2, and then I'm going to make a really horrible division signal. Now I'm going to try that again. That division symbol should be a little flatter. Oh, it's still not working. The horizontal lines on the tablet are not my strong point. We're going to do 3x cubed, and I'm paying attention to the variables. I want my variables to decrease by 1. If they don't, I'm going to put a placeholder in of an x squared if it's missing or whatever. If there's a missing term, I'll put a 0x squared. This one has all of them. It has the third power, second power, and then first power and 0 power, right, of x. So I have this set up. So now what I'm going to do long division is I'm going to look at this lead term in this polynomial and the lead term in this polynomial, and I'm going to say how many, if I divided 3x squared or 3x cubed by x, in other words, doing this, 3x cubed divided by x, I would get 3x squared, right? Because one of these would cancel. So that is what I want to put up here, because what I've done is the same thing I did here. I divided 6 into 13. I'm dividing x into 3x cubed. I get 3x squared. Now I have to multiply by this entire thing. So 3x squared times x is 3x cubed. And that's what I wanted. If this doesn't match, you didn't pick the right number here. All right, so then I do a negative 2 times 3x squared, and that gives me a negative 6x squared. Now, what did we do over here? We subtracted, right? So now I'm going to subtract. 3x cubed minus 3x cubed gives me 0. Negative 7x squared minus a negative is plus a positive. So negative 7x squared plus 6x squared is negative x squared. And I do the same thing I did before. I bring down the next term. So now, I'm now looking at x minus 2 going into this. Just like I did, I wanted to get it into 12 over here. I'm going to look at x going into a negative x squared. So negative x squared divided by x is equal to negative x. Whoops, that's supposed to be a negative x. So this is going to be a negative x up here. And now I multiply. Same thing we did before. So now I'm going to do x, or negative x times x. That gives me a negative x squared. I'm going to do a negative x times a negative 2. That gives me a positive 2x. And I'm going to subtract again. Negative x squared minus the negative x squared is 0. 9x minus 2x is 7x. And then I bring down the 14. Finally, I'm going to get out here and say, all right, I've got 7x left. I want to know how many times does x go into that. Well, 7x divided by x is 7. So I would put a positive 7 here. That times x minus 2 would give me 7x, and minus 2 gives me a negative 14. When I subtract, I get 0. That means there's a remainder of 0. So the solution to this up here would be 3x squared minus x plus 7. And it goes in evenly. So x minus 2 is a factor of this, in other words. So if I took x minus 2 and multiplied it by this, I'd get back this top, is what it comes down to. All right, this is long division. So Let's look at another one. Let's see. Let's do, let's do this one. Let's do a different type now. All right. Let's do this. If we have, let's say 2x squared minus 5x minus 3, and we're doing that divided by x minus 3. Now, again, I can set this up with long division. If I do x minus 3 divided into 2x squared minus 5x minus 3, I can do this again. So I get, first I look at x going into 2x squared. I would get a 2x. That would give me, when I multiply, 2x squared minus 6x. I subtract and I get a positive x. X into x is a positive 1. And that would give me, when I multiply, x minus 3. I have that 3 there, so this is x minus 3, and I would get a remainder of 0. When you get used to doing this, you can do it rather quickly. All right. Now, one more. If we had, I'm going to go back to black here. 2x cubed minus 5x squared minus 4. And we are going to divide that. I'm just going to set this up right off the bat. We are going to divide this by x minus 2. So if we do that, x minus 2 into this, well, first we look at x into 2x cubed. Now, there's one thing here. I'm going to change this right off the bat. This was 5x squared minus 4, but I told you before, when I don't have an x, I'm going to put in plus 0x, then minus 4. All right, that's if we were given this problem as, say, 2x cubed minus 5x squared minus 4 divided by x minus 2. I see that there's a missing x. I'm going to put it in here. I just want it as a placeholder, and you'll see why in a minute. All right, so when you see that missing term, just throw a 0 in front of the appropriate x. So x into 2x squared, or 2x cubed, would leave me 2x squared. When I multiply this, I would get 2x cubed, and then 2x squared times negative 2 would be a negative 4x squared. I subtract, which means adding there, and I would have a negative x squared plus 0x. Now, x into negative x squared is a negative x, and we would get negative x squared plus 2x. We multiply negative x times negative 2, we get a positive 2x. Now I subtract. That's why that 0x comes in handy. Do you see it there? And then I can bring down the 4, the negative 4. And x into this is a negative 2. So negative 2 times that. Negative 2 times negative 2 makes a positive 4. When I subtract, you got to be careful there. I get a negative 8. So this didn't work out with a 0 remainder. So how do we write that as a solution? Well, we think of the solution for this as this. This would be equivalent to, all right, it would be 2x squared minus x minus 2. And then this is a negative, so I'm going to put a negative, and I have 8 left over. It's still being divided by x minus 2. So we would write it that way. And this would be the quotient there. This was the remainder. Remainder was 8, which 8 is still being divided by x minus 2. All right, so that would be how that works. And that's long division, guys. It's going to come in different forms, and we're going to give you some practice problems. One last thing, and this one I think you've done before, maybe. It's one of those that it depends on who you had. It seems like sometimes they'll bring it up. This one is great if you have division by a binomial where you have something that's simply in the form like you're dividing by x and then plus or minus some value, some constant. If you have that where this is 1 and this is a number added or subtracted and you're using division, you can use this. It's the only time you can use synthetic division. All right, so let's look back at a couple of those problems we just did. We did this one where we had 2x squared minus 5x minus 3. And we said we were going to divide this by x minus 3. This is, again, division by something that matches this, right? So the way we set this up, we just take our coefficients on this top piece. So the coefficient of that is 2, -5, and -3. Now, again, if there was any missing x's, it went down 2, 1, 0, so we're good. But if there was a missing one, we'd have to put a 0 in. And then we make a box over in the corner. In the box would be whatever makes this 0. This is in the form x minus r, where r is the root, and the root is what makes this a 0, right? So the root would be 3. And so we would put 3 in there because 3 minus 3 is 0. So that's what we want in that box. Leave ourselves a space and draw a line. All right, so now, this is kind of gimmicky. That's why I don't like it as much, because it only works when we have x plus or minus a constant we can divide by. But it is nice because if you get the way of doing it, it works really nicely and very quickly. Now, what I always say is everything above this line, we are going to be adding. Everything below this line, we are going to be multiplying. All right, so we start out looking at this as columns. This column, we start out, we have nothing here, so we're just adding 2 plus 0 gives us 2. We're always adding downward. And then anything that comes below this now gets multiplied by whatever's in the box. So 2 times 3, and it'll go in the next column up here as 6. So now I have these two in this column. I have to add them. They're above the line. -5 plus 6 is 1. Then I have a number below. I multiply it. 3 times 1 is 3. I now have a number above. I add these. I get 0. This last column is going to be a remainder. Remember, this is what we got before. If you look back on this same problem, back here, we got 2x plus 1 with a remainder of 0. Now let's look at what we have here. What we have here are the coefficients. This and this are the coefficients of our polynomial, our quotient. Now, our quotient, because we divided by a degree 1 x value, all of these would go down 1. So it started out as squared, so now it's going to be 2x. It goes down 1 degree from the original divisor, the thing that was being divided. So 2x, and then it goes down by 1. So this is plus 1 times x to the 0. So this would be our quotient. All right, this is, again, a little gimmicky. You start out with all your coefficients and your root in the box, whatever makes that divisor 0. So now we add everything above, we get 2. We multiply everything below, we get 6. We add, multiply, add. We get our coefficients here. That tells us our quotient. This would be our solution. All right, let's do another one. If we go back to this one where I have 2x cubed minus 5x squared minus 4 divided by x minus 2. Again, my divisor is a nice polynomial or binomial with 1 in front of the x and plus or minus a constant. So I can take my coefficients here. I can do synthetic division. 2 is for the x cubed. X squared has a -5. X to the 0 isn't here, so I have to put a 0 in there. Just like we did in the long division, we have to do it here. Otherwise, everything will get messed up. And then we have a -4 for the x to the 0. In the box would go, well, look at this, a 2 is going to go in there. Now, if we had x plus 2 we were dividing in, it would be a -2 in there, just to be clear. We give ourselves a space, and now we start our addition. 2 plus 0 is 2. 2 times 2 is 4. -5 and 4 added make -1. -1 times 2 is -2. Add, I get -2. -2 times 2 is -4. I'm sorry, -2 times, did I do that right? Yeah, -8. I'm sorry. I totally gapped there. That happens, guys, even for us. I add and I get -8. So now, what do we have? Again, we started out with cubed, right? This is, well, where's my pen? There it is. we started out cubed. So when I divide by a degree 1, it's going to come down by 1. So these are the coefficients of my solution. And my solution would be now 2x squared, because we come from cubed, minus x minus 2 minus 8 over my x minus 2. So we get the same solution we did before, and we're good to go. So that's division by a monomial, polynomial division, and synthetic division. Polynomial division will work for any combination of two polynomials. Synthetic division is a little gimmicky, but it does work really well for x minus 2, x plus 4, all those kind of things. So again, you're going to get some practice on this, and we will answer your questions tomorrow. All right, have a wonderful day, folks, and I will see you soon.